Hello, let's continue with a new chapter, Chapter 5 and Section 5.1 on circles. Our objectives will be to 1. Find the center and radius of a circle, 2. Graph circles, and 3. Find equations of circles. Center and radius of circles. The definition of a circle is a set of all points on a plane that are equidistant from a fixed point. So if there's a fixed point and all these lines are the exact same length, then the collection of them will make this figure, which is how a circle is defined. The fixed point mentioned in the definition is the center of the circle, and the fixed distance is the radius. So the distance from our center to the endpoint, that is called a radius. And every segment or line that can be drawn from the center to the endpoint of the circle is a radius. In order to derive the standard form of the equation of a circle, we use the distance formula, which is this. This is our distance formula. And this distance can be used from having any 2 points, x1, y1, and x2, y2. And these are the points that we will use to plug into the formula. Every point x, y of a circle must be the length of the radius r from the center h, k. Therefore, using the distance formula, we have, so if we replace distance with your radius, because that would be the distance from an endpoint to the center, then we have our radius. And squaring both sides will give us our formula. So this is your circle formula, or circle equation. X minus h squared plus y minus k squared equals r squared. The standard form of the equation of a circle with radius r and center h, k. If I can point out, notice our radius is r, but we're given r squared. So therefore, if we have r squared, we got to take the square root so that we can result in just r. Example 1. Find the center and radius of the following circles. For A, we have x squared plus y squared equals 16. All right, we have our standard form above right here. Now, we notice that there is a number that should be subtracted from h in parentheses and a number that should be subtracted from y in parentheses. So that h and that k, that will produce our center. Notice there's not a minus h and a minus k. If you want to, you can always try to make it fit that standard form. And if so, we would see that we have a center of 0, 0. So our center is 0, 0. R squared is 16. So therefore, our radius r is 4. As a distance, we only consider the radius of the positive square root, so 16. B, we have x plus 2 squared and y minus 1 squared. So if I can point out the formula, notice that we have a minus. So minus a number and minus a number. So what this does is that causes a sign change. So we'll see that in example B. If I have x plus 2 squared plus y minus 1 squared equals 9, noting that the standard form of the equation of a circle has the expression x minus h and y minus k, we find the center hk by recognizing that x plus 2 and y minus 1 gives us negative 2 and positive 1. But we're like, hey, if it's positive, why do we have a negative? Well, remember, it causes a sign change because our formula has that minus. So we wanted to make it fit that formula. So if I had x minus h squared and y minus k squared, to make it fit that, it would be x minus 2 and negative 2 plus y minus 1. So see here how I have a minus 2. Here I have a 1. And that would be because if I have x and a negative, make a positive, I have x plus 2, which is what we have. So in a sense, just know that change the signs to positive, from positive to negative, and negative to positive. When determining two coordinates of the center, we take the opposite sign of each expression. So x plus 2 and y minus 1, since the formula has two expressions as x minus h and y minus k. And our radius, while we have r squared is 9, we take the square root of 9, we get 3. All right, what about c? Okay, see a negative 3 and a plus 2. So therefore, my center is positive 3 and negative 2. So we have center of positive 3 and negative 2. And my radius, well, r squared is 11, so I take the square root. So my radius is square root of 11. If for graphing purposes, you can punch into your calculator and get a decimal answer. D. X squared plus y squared plus 10x minus 6y plus 18 equals 0. For the standard equation, we need to make it fit this formula. One very important observation should be the single copy of each variable x and y. As you will see here, and with other three conic sections of this chapter, completing the square is a necessary step for writing an equation. In standard form, anytime there are both x squares and x's, or y squares and y's in terms of the equation. So in this page for this section, I didn't include a review for completing the square. Make sure you go over it if you feel like that's something you might have forgotten or would like to refreshen up your memory on. All right, so we want to find my center here, right? But I need to have it as in this form, right? So in order to do so that I can pick out my center, I need to complete the square. All right, so we have to rewrite our equations. We have to group our x's, and we have to group our y's. And everything else, we set it equal to the other side. So constants on the other side. All right, now I need to complete the square. Completing the square is this formula that we learned. It's b over 2 squared. And we take our b term from our quadratic. So our b would be 10. So that would be 10 divided by 2 squared. 10 divided by 2 is 5 squared. And so we get 25. So I have to add 25 to both sides. All right, same thing with our y's. We use that same formula, b over 2 squared. Our b from our y is negative 6. So I have negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3. And negative 3 squared is 9. So we're going to add 9 to both sides, such as we have here. Okay, now I need to factor my x's and my y's. Now notice you're going to factor to get the same thing twice, so you can write it as parentheses squared. And as a hint, it's always a number before you square. So I know I should end up with a 5 and a negative 3. So once I factor on the left side and combine the values on the right side, I'm left with x plus 5 squared. That was my value for my x's. And y minus 3 squared. That was my value for my y's. And negative 18 plus 25 plus 9, well, that gave us 16. All right, now I can easily pick out my center. It's negative 5 and positive 3. with a radius of 4. Same thing for E. All right, we notice it's not a standard form, so I need to complete the square. Okay, so I need to group my x's and my y's. So here I have all of my x's and all of my y's. In this case, I only had one y, and that's okay. And everything else that is not an x or a y on the other side of our equal sign, our constants. All right, so I don't have to do anything here because there's not another y. So we're done with our y's. However, for our x's, I have to complete the square because I have this x, and I want to have only an x squared in parentheses. So we use our formula, that b over 2 squared. So my b in this case would be 8. We have 8 over 2 squared. 8 divided by 2 is 4, and we're going to add 16 to both sides. So plus 16 plus 16. We show our work here, and now we complete the square. And it always ends up being the number you have right before you square it. So right before we squared it, we have positive 4. So I know I should have x plus 4 squared, such as we have here once we factor. All right, and on our right side of our equation, we have negative 18 plus 16 gives us negative 2. All right, when I take the square root of negative 2, it's not a real number. We get an I. The graph does not produce a circle and is called a degenerate case. When solving for the radius r, only positive values for r will produce circles. If the formula yields of r squared equals 0, the graph will be a single point, namely the center. If r squared is negative, no graph will exist. All right, let's continue with graphing circles. In the previous exercises on circles, we were focused on finding the center and radius. The material in this portion of this section will show how to use both the center and radius to graph a circle. All right, let's take a look at example 1. Let's repeat the problem and let's graph it. So let's graph our circle. Without the aid of mathematical tools called a compass, we draw a circle by locating the center first. Then from the circle, we travel the distance of the radius in all 4 directions, left, right, up, down. So we have our center, we go up, down, right, and left. And that would give me enough points to figure out how my circle is supposed to look like. And that's your game plan. Using these 4 points, we draw a round circle. From earlier, we determined that the circle x squared plus y squared equals 16 has a center at 0, 0 and a radius at 4. Starting with the center at 0, 0, 4 units in each direction will give you the 4 points. So our radius up, our radius to the right, our radius down, our radius to the left. In this case, my radius was 4. So here we have my circle. I have my center, and then I go 4 units up, and then 4 units to the left, 4 units down, and 4 units to the right to produce my circle. Now let's take a look at the next graph. We determined that our center was negative 2, 1, and my radius was 3. All right, so let's plot my center at negative 2, 1. And from there, I just count 3 tick marks up, down, left, right. So I go 1, 2, 3, new point. 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 And if possible, make sure you label them as you go. So if I went 3 up, I'm going to add 3 to my y. If I went 3 down, I'm going to subtract 3 to my y. If I went 3 to the right, I'm going to add 3 to my x. And if I went to the left, I'm going to subtract 3 to my x. Let me erase all my funny marks, but you write as many marks as you feel if you feel necessary. I'm just trying to guide you as best as I can. As we are finding the 4 points to graph a circle, we should realize that these points can be found by adding and subtracting the value of our radius from each of the coordinates in the center. This will become more obvious on our next example. So if we have our center x comma y, or I'm sorry, h comma k, if I add and subtract my radius, and add and subtract my radius, it'll produce those 4 points that I'm looking for. So let's take the graph from example C. We have our center at 3 and negative 2, and our radius is square root of 11. That's not an easy number to count up, down, left, right. But if I punch in my calculator, it's about 3.3. So if I want to label my points, I can go ahead and take my x, which is 3, and subtract 3.3. I can also add the 3.3, which is my radius. Take my y, which was negative 2, and add 3.3, negative 2, and subtract 3.3. And I can find my points that way to get my circle. All right, from example D, we found our standard equation of a line, and we got a center at negative 5, comma 3, and a radius at 4. So let's plot our center, and let's move 4 up, down, left, and right. So we get our new 4 points. So if I move it up, 3 plus 4, we get 7. If I move it down, 3 minus 4, I get negative 1. Now I look at my x's, because my x's move from left to right, so I subtract left and right. Negative 5 minus 4, we get negative 9. Negative 5 plus 4, we get negative 1. That's how I find my other points. Finding the equation of a circle. The final topic in the section can be thought of as a reverse equation as compared to each of the questions above. In every exercise so far, we started with the equation and were asked to find the information about the circle and or to graph it. Now we will start with the given information, and the question will ask us to find the equation of the circle. Example 1. Find the equation in standard form of circle with center 2, negative 5 and a radius of 6. This question explicitly states both the center and the radius, so using the standard equation of a circle with center h, k and radius r will be helpful. So we know we have a center of 2 and negative 5. So in my circle formula, I know it would be x minus 2 because I changed my sign, square plus y, and I would like to skip just the answer. If I have a minus 5, I'll write a plus 5 squared. Know that your h is always attached to your x's and your k is always attached to your y's. So that's how we see those numbers lining up. Lastly, we're told that our radius is 6. So to find our radius squared, we have to square it. So 6 squared is 36. That would be our answer. Example 4. Find the equation in standard form of a circle with center negative 3, 1, with the circle passing through the point 1, 5. All right. So here we have a picture that helps us out. We know we have a center, and if I have any other point on my circle, it would have to be an endpoint. So therefore, to find my equation, as we saw above, I need 2 pieces. I need my center and I need my radius. So I know that this distance will give me my desired radius. This question explicitly states the center but not the radius. So using the standard equation of a circle with center h comma k and radius r, we have these values. We have our center. To find the radius of a circle, we could go back and find the distance formula. So that was my first hunch. We need to find that radius. But because we have the formula of a circle, we can go about it a bit differently. But since the equation of a circle is derived from the distance formula, we know that the circle passes through the point 1, comma 5, and we can substitute this point into our equation. So we're going to let 1 be x and y be 5. All right, so we make that change with our x being 1 and my y being 5. I replace it into my formula, and by some arithmetic and algebra, I get my radius squared is 32. So now with my center, h and k, I have now found my radius squared. R squared is 32. So that would produce our answer. Example 5. Find the equation in standard form of a circle with a diameter with endpoints at 2, comma, -5 and 6, comma, 1. All right, so I know at the very center point would lie my center, and the distance from my endpoint is my radius. So I need to remember that my diameter is 2 times my radius. This example does not explicitly state the center or radius. However, if we recall that the diameter of a line that crosses the entire circle to the center, we know the midpoint of two given points is the center of the circle. So given these 2 points, our first goal is to find our midpoint. Our midpoint will help us find the center. All right, so to find the midpoint, you take your x's and add them. You take x1 and x2 from 2 points. You take your y's, y1 and y2 from both points, and you divide them by 2 separately. All right, so for this problem, let's label our points. x1, y1, x2, y2. I like to label them, it makes it easier to, well, for me, it makes it less likely to make a silly mistake. So if I replace them, x1 would be, or it doesn't matter which one's x1 or x2, I want to stick to what the text has. So let me erase them and write them again. So your text has this as x1, x1, y1, x2, y2. All right, so x1 would be 2 and x2 would be 6. We'll divide that by 2. Our y1 would be -5, or y2 would be 1, and we divide that by 2. So 2 plus 6 gives us 8. 8 divided by 2, we get 4. -5 plus 1, we get 4. -4 divided by 2, we get -2. So that would be our center. Using 2, comma, -4, comma, -2 for the center, we have our equation. But we need to find the radius. Well, from here, I can go ahead and do it like I did the previous problem. I can use any of the points of my circle and substitute them, the x and the y. So I'll replace x and y with the values from one of the points that I have above. We now follow the same process as example 4 to find the radius. Using either of the points, we substitute it into our equation. So let's use 6, comma 1. So I'll let x be 6 and I'll let y be 1, such as we have here. And I work it out. 6 minus 4 gives me 2, 1 plus 2 gives me 3, and that simplifies to be 13. So for my formula, I just need to find that r squared. We have that x minus 4 squared plus y plus 2 squared equals r squared, which is 13. All right, that's it for our section, our first section, chapter 5. If you have any questions, feel free to email me. Thank you.